Do you guys have any question before I start regarding anything? Okay. So this is our project 3. So mostly I'm going to talk about this project at first. Then we're going to go over um, what like I have missed one problem on chapter 9. So we're going to go through and like finish that chapter. So first of all, project 3, same as before, you guys will be working as like group as a group. So just to mention one thing, I think I forgot. On the first project, I remember I told you guys like write your name up there on the comment on each of the .m files. So you'll need to do that. Okay, I think some of you have missed it on this project, which is okay. Which is okay. It's all good. But in project 3, I would like to see that. Okay, so on the first line of each your code file, write your names. So whenever you're working as a group, write all of your names. Um, yeah. Okay. Any question? Okay. So project 3 is kind of like project 2. It's like it's from the book. It's like a homework problem, which is like 9.13 on page 170. What it like kind of tells you is like I will also like show the problem to figure out two things. The first thing is like you have to figure out there is a transfer or Leslie matrix given. Using that with the initial vector, you'll need to find vectors at like time step 1, 2, 4, 5, or 20, or like some kind of like time steps. So you have done this in your exams, and also like we have done this in class. So you can like literally do this with your hand and try to like match your answer with the stuff you get from the code, okay, MATLAB code. And what else? There will be like 2 new um, MATLAB files. So we are not going to use that like histogram and linear regression line again. So these 2 MATLAB files, what they're going to do is like one of them is called eco succession table.m. So what this does is like it kind of like calculates the vectors using that matrix multiplication with the initial vector. And the other one, which is called ig.m. So maybe you can guess it, like it's like for the eigenvalue and eigenvector. Okay, that's what that will do. Okay, now let's look at the actual problem, 9.13. Give me a second. I'll have to pull that up. So I'm showing this for this project because I think the last one I just gave you guys, and I thought that will be okay. And yeah, you guys haven't seen this kind of stuff before. Like not most of you were like confused, like what to do, what should you need to solve. So I'm just like going over the problems a bit on this project. So even though it might not make sense to you guys right now, because I think most of you haven't seen the problem, haven't read through the PDF yet, but I am going to record this so you can like when you start your project, you can watch this video again. Maybe it will be painful to you. Yeah, my voice is not the best voice ever, but you guys will know what you guys need to solve or what you guys need to compute in your project. Okay. Give me a second. Where's the book? Here it is. Okay. Okay. I haven't used Zoom in a while. Okay. Can you guys see the uh, book, I guess? Uh, okay. I'm going to take this as like you guys can see the book. Okay. So this is in page 170 of chapter 9. What you guys have to do is like solve this 9.13 in MATLAB. Okay. That's what you're going to do. So I'm going to run down like what this problem is in like, I'm not going to read through the whole thing. It's like you are given a transfer matrix or a Leslie it's not a transfer matrix, it's actually a Leslie matrix, and you're also given an initial population, So on the first part, on this A part, okay, should have opened it on iPad, I guess. Like I could have like annotated or something. So on the first part, what they're asking you, like on different time steps, what will be your eigenvector values? So you have done this in your exams too, like by hand, right? So that's what you need to do on the first part. And on the second part, part B and C, what it's like actually telling you to summarize is like find the eigenvalue, find the dominant eigenvalue, find the eigenvectors, find normalized eigenvector. Okay, that's it, nothing else. Okay, any question? Okay. I'm gonna stop sharing this one, and I'm gonna pull up my, where is my MATLAB? Okay, MATLAB here, and I'll share that. Okay, can we see the MATLAB code? I just need like one yes, like the
Yeah,
other stuff. Okay, thank you, Madison, maybe, yeah. Okay, so remember here, please write your name. Most of you didn't uh, for the project too. Okay, so write all of your names. Let's say like you have two or three people. Like let's say I'm on my own, so I'm gonna go with my other alias, I guess, Mr. T. Okay, write your names up there. And what this method file will do is like it will calculate the vector values for different time steps. Okay, so this part over here, this is the Leslie matrix or the transfer matrix. You need to like modify this as like what it is telling you in what 9.30. So modify this part as mentioned in 9.13 problem statement. Then this is the initial vector. Also modify this part as mentioned in 9.13. Then you don't need to worry about this printf stuff. Then, okay, this part over here. This is, I'm sorry about that. I'm like not feeling that well. Um, these are the time steps that your code will figure out what will be the vector values in that respective time step. So when I'm saying like 10, it's like v of 10. So in some sense, if I write it here, because I don't have anywhere else to write, so this means v of 10 will be equal to what? Then we have v of 20. So that means what's going to be v of 20? Like after 20 years, what will be the value of the vectors? And let's say the last one, 450. So it's like after 450 years, uh, what will be the value? Okay. Yeah, Ayush, I'm recording this. Like, I know, like, so the thing is, I know, like, most of you should either be confused. Most of you, like, he just posted the project yesterday, don't care about the project right now, which is okay. And some of you are like me, are like, I don't need to know this right now. I'll figure it out later. So it's kind of like for all of you to look back later. Okay. Okay. So still, if you have any question, like more than welcome to ask me. So these are the time steps that you're like trying to figure out the values for. So if I, and this is, see, this is like t power to the power t. If you remember, that is how we find the vector values actually. See, so in this t, they're gonna plug in 10, they're gonna plug in 20, they're gonna plug in 30, they're gonna plug in 40, they're gonna plug in 450. Because yeah, MATLAB can do that. Okay. If you are doing it by hand, then it would have taken more time. If I run it, if you look, okay, let's, okay, give me a second, okay, here. Mm, okay, clear all. Okay, whatever. Okay, so when I'm running it, what is happening is like in my command window, I don't know if you can see this. I think you guys should be able to see it. In my command window, these are the values I'm getting. And what you need to do is like, that's what I wrote in the PDF. You need to screenshot this and put this on your write-up. And in the first row, when it says like t equals to 10, and you have values for u, s, and d, that's the vector value. So that's like v of 10, and all the different classes like u and s, us and d, us and d, you have like different values. And let's say go on like 450, same thing. You have different values. That's what you're trying to figure out. You can modify this. So also modify this part as mentioned in 9.13. So let's say we want to figure out the first 3 years, what will happen. So I'm going to modify this 1, 2, 3, and let's say my favorite number. Let's say I'm going to go with 13. Okay. And now if I run this, can you see like this? So one time step, second time step, three time step, then 13. So these are the values. Any question from anyone? Okay. If you guys don't have any question, then let's move on to the next one. So this is one of the codes. Second code, okay? It's called diag.m. I'm gonna still do this. I'm gonna write my name up there. And then this is the Leslie matrix we're gonna be working on. So what this code file is actually doing is it's finding the eigenvector. Let's write this. Even though it's written here, I'm gonna still write this so you guys can like understand what this function is doing. Finding eigenvalue, finding the dominant eigenvalue and the eigenvector of the matrix A, little matrix, and normalized eigenvector. So that's all this uh, what this matrix file is doing. Eigenvalue, dominant eigenvalue, eigenvector, and normalized eigenvector. So we have this a transfer or Leslie matrix. Then this line over here, this actually gives you the eigenvector and the eigenvalue. V is your eigenvector, lambda is your eigenvalue. Okay. Then uh, after that, it's like, how should I say it? It's like the code kind of like does stuff for you, so you don't need to like worry about it. And yeah, I'm not gonna say anything more on this from this code. If you have any trouble, obviously you can ask me. And that is it. And I'm telling you one thing, it's easier. It's easier than the histogram and linear regression one. Okay? It's literally easier. This is the simplest, I'm gonna say, even from the first project. This is way simpler. Okay? So if you're facing any trouble, ask me all obviously. If not, that's also good. Uh, why like one like I should have asked this question, like why am I giving you like a simpler task on the last one? Because of two things. One thing, let's not record this. By the way, how do I wait?